Hi, everyone. Good morning. Today's topic is Introduction to Discrete Choice Experiments and Models. And this is an advanced introduction to new product design compared to what we have done for the conjoint analysis. So I'm going to explain in this lecture the background theory to discrete choice experiments, the common terms in discrete choice experiments, how we design discrete choice experiments, analysis of these experiments, and how they are different from how the analysis is different from conjoint. And I will give you a recommended reading list should you be interested in exploring this topic more. And then finally, we are going to discuss the conjoint analysis simulator, which is what you're going to need for your project analysis. All right, so the first is the background theory to discrete choice experiments. So if you analyze your own experiences as consumers, we are making choices every day, right? You go to a grocery store, you are choosing products from the aisle. Should I buy Heinz ketchup or should I buy another brand? Should I buy Cadbury's dairy milk chocolate or should I buy another Lindt chocolate? So I'm making a choice. Should I choose Cadbury's or should I choose Lindt? Again, when we are applying for jobs, right, should I choose to apply for this company or do I choose to apply for another alternative company which is more suitable for my needs? So we are making choices on an everyday basis. Now, these choices are directly related to us because we derive some utility by making the choice, buying the product, and consuming the product. But you will also notice that in the public settings also, we make choices. For example, the government makes a decision, where to install the windmills, where to, construct highways, what areas are best suited for solar panels, etc. And all these decisions, these choices, they have an impact on the public welfare. So be it personal choice or be it choice for government decision making, it all has makes an impact to the utility that the consumers derive from the choices made. So why choice models? So when you have the kind of data available to you that, for example, the consumer goes and buys in the store, right? You go to the grocery store, you buy. So let's say that's a value of 1. If you buy, it is equal to 1. If you do not buy, then it is equal to 0. Equals to 0. So we make these kind of binary decisions every day, and that is called making a choice. If you're buying or you're not buying, that is. Now, these kind of instances, because they are very common in our daily lives, so this type of data is very easily available. For example, the scanners, the web logs, did you visit a site or did you not visit the site? All these types of data are easily available. This is called as choice data. Whenever you have a column in your data, which is 0 and 1, which indicates the choice that the consumer has made, that is called as choice data. This type of data is easily available at the stores. You can collect this data through surveys. And there's a lot that you can do with this type of data. For example, you can do predictive modeling to understand, how an individual's past choices predict their future actions. That is, what are they more likely to choose in the future when they go to a store based on what they chose in the past. Then it can be used for generating diagnostics, that is, to identify the important drivers that drive these consumer choices. For example, you are more driven to buy Cadbury's because you love the packaging, and you're more driven to buy Lindt chocolate because you love, you like the flavor. So what are those factors which drive the consumers to make certain choices? So those type of diagnostics can be easily done using the choice data. Choice data is very useful in segmenting the market into distinct segments of consumers based on the similarities of their choice driving process. So for example, is there a unique segment of consumers that is driven by price, and all the choices that they make in buying the products is based on their sensitivity to price? So that is called segmenting the consumers. So the choice models are very widely used in several disciplines, and that includes the economics disciplines, mathematics and statistics, applied disciplines like marketing, transportation, applied economics, and in psychology as well, to understand how consumers behave, how consumers choose a particular mode of transport when they are traveling to their workplace or to another place. So these models are very widely used. Now, what is the theoretical basis of these models? So the choice models are based on a theory called as the random utility theory. Now, as per this theory, the important part of this theory is that the decisions that the consumers make, they are based, as a consumer, the decision that you will take to buy a product is based on the overall utility that you will derive from that product. And that utility is a function of the observable preferences for those attributes. So consumers are buying products because they have a certain preference for the product attributes. That is why the overall utility for an alternative is higher. So your overall utility for Cadbury's is high because there are some product attributes that you really value when you are making purchase of Cadbury's chocolates. So there are two components to the consumer's utility. So one is the observed preference for the product attributes, and the other component is this term E, which is the unobserved component. So there may be other factors, a lot of other factors or noise that might drive the consumer's decisions. So maybe, for example, consumers word of mouth might have influenced a consumer to go into the store and try a particular flavor of Cadbury's chocolates. So all the unobserved random factors that influence the choice of a consumer, those all also are incorporated into the consumer's decision making. And so this is what random utility theory is all about. In other words, the consumer is assumed to choose the alternative that provides the highest utility among all the alternatives. And an important assumption of this theory is that the consumers are rational decision makers, and they seek to optimize their choice problem in a way so as to choose the best option that is available out there. So in other words, it is assumed that the consumers are utility maximizers. They are always maximizing their utility from a set of options that is available to them. All right, so the common terms. So just as you conduct a conjoint analysis to understand the new product design, if you want to design a new product, if you want to make it slightly more complicated, slightly more elicit more information, then what you can do is you can design discrete choice experiments. So discrete choice experiments, some of the common terms involved are those that you're already familiar with, and you have used these terms like alternatives, attributes, attribute levels for conjoint. So here are 5 options. So this is, these are cars, different types of cars, and their attributes are given. So these are 5 alternatives or 5 options available to the consumer to make a choice from. These are the attributes. For example, body type is an attribute, country of manufacturing is an attribute, and country of manufacturing has different levels, and those levels are given here. For example, the country of manufacturing are Thailand, Korea, and Japan. So there are 3 levels to the country of manufacturing. So you can go take a look at all of the attributes and see how many unique levels there are. So in the conjoint experiments, you will notice that there are all these alternatives given to the consumer. These are the levels that have been chosen in this particular design for these attributes, and the consumer is asked to choose from all of these options their most preferred option and their least preferred option. So that is the difference here from conjoint. In conjoint, the consumers are asked to rank all these options. So from 1 to 5, which is rank all of these options, and the consumer can rank, this is my first preference, this is my second preference, this is my third preference, this is my fourth preference, and this is the fifth preference, right? And on the basis of those preferences, then we determine what are the sub-utilities for each of these attributes. But in conjoint analysis, instead of asking them to indicate their preferences, we actually ask them to choose. So make a choice. Which is your most preferred vehicle? So for example, I can click on this. This is my most preferred vehicle, and this is my least preferred vehicle. So you are getting the thing that you're losing. There's some information that you're losing out in this case. That is, you are getting only the best preference and the worst preference, but you are missing out on consumer's preference for these options. But we'll see the advantage of these models in the future slides. Okay, so some of the key terms used in discrete choice experiments, also called as DCE, is first is discrete choice. Discrete means there are mutually exclusive options given to the consumer, and the consumer has to select one of the options from that set of mutually exclusive alternatives. The second term is experimental design. Now, design refers to the attributes and the attribute levels that have been used in the experiment, which is similar to what you have done in conjoint. The other term used is orthogonal design. That is, the attributes are assumed to be, they are estimated, the attributes estimated are assumed to be independent of one another. That is, they are not correlated. So price is very different from body type, from the country of origin. So there is no commonality between these different attributes. Then we have blocking. Blocking is an additional feature which is unique to discrete choice experiments. Blocking essentially means that you're going to, because you have a large number of alternatives in discrete choice experiments with a large number of attributes. So the designs can be as high as 100 or even higher. So in that case, because it's not possible for one consumer to choose from 100 options, so what is done is we take subsets of all the options and present them to blocks of consumers. So it's an experimental setting where randomly the consumers are going to be assigned a random number of options to make a choice. So that is called as blocking. So blocking refers to the design being given to selected blocks of respondents. Now, designing the discrete choice experiments. So what are the unique features when you're designing these experiments? First, it is important to understand preference and choice. So a consumer will form his preference or towards a product based on the attribute. So you are, for example, if you are giving 3 options of cars, they will tell you their preference based on the attributes such as the engine type, the country of origin, the fuel type, etc. However, external factors like prices and personal characteristics can also affect the preferences of the consumer. So when the consumers tell you their preference, that this is the first preference, this is the second preference, that is called as stated preference data. You can ask that in a survey or in an experimental setting. For example, how much do you like this? How likely are you to buy this product? Or which one of these options are you going to choose? So when you are doing discrete choice experiments, you are getting data which is called as the stated preference data. On the other hand, if you're going to grocery stores to do your groceries, now each time you swipe your credit card at the counter, all your data from that card is being recorded in the form of, at the back end of that system. And that is called as revealed preference. By swiping the card, you have revealed what items you like to buy in this particular store. So you bought 2 bottles of Pantene shampoo and conditioner at a certain price. You bought another item at a discount. So revealed preference data uses your information to tell us about what this consumer likes to buy, what brands are their favorite, what prices they like to buy them at, and at whether they bought the products on discounts or deals. And from those, you can then infer the consumer's, choice decisions. So that is another different type of data. Now, the discrete choice experiment data, which is called as the stated preference data that we discussed on the last slide, it has some advantages over the store data or the revealed preference data. Some of the advantages are that it is very difficult to obtain this type of data. So, you can design the experiments or the surveys, and then you obviate the need of data problems such as obtaining the data or coding issues in the data or human errors in the data. Right? If you're designing new products, you can introduce new features and new services and new attributes to figure out the consumer's preference for those new attributes. Similarly, a lot of times, for example, price is highly correlated to discount if consumers are buying products in stores. So it is very difficult to make inferences from reveal preference data if you do not recognize that there are 2 columns where price is highly correlated to discount. So should you use only discount column or should you use only pricing in your model? So those sorts of problems can be eliminated using stated preference data. Revealed preference data can be time consuming, it's very costly, and it might have less information depending on the quality of the data. The no revealed preference data for products, goods can be traded in the real markets. In other words, that this data is very difficult to obtain. For example, superannuation data, the companies will not be willing to give away their consumers' information because it is highly confidential. And if we have both these types of data sets available to us, then we can combine them to derive even more robust results. Next, we come to experimental design methods in practice. So when we are conducting discrete choice experiments, then what kind of softwares do we use? So there are some, we cannot do the analysis in Excel for these type of experiments. Then we have to use SPSS, SAS, QC, Engine, R. R is available for free. So for those students who have some idea of R, you can try these experiments. And there are also, public libraries available to come up with designs for your discrete choice experiments. So you can visit these websites and take a look. All right. Next is just a demonstration of a very simple design for a discrete choice experiment to illustrate to you how it would differ, how presenting the information in a DCE would be different from that in a conjoint analysis. So let's take the example of pizza. There are two pizza brands. The brand name is not given, but let's call them as Pizza A and Pizza B. So these are the attributes: pizza type of crust, ingredients, price, and delivery time. So there are 5 attributes and with 2 levels each. So the number of combinations, it can be very large. For 5 attributes, that is 2 raised to power 5, that is almost 32 combinations. So when we are designing discrete choice experiments, this is one such design. So instead of taking all 32 designs, what we do is you can select a few designs by going to this particular website, which will create the design for you for discrete choice experiments. Now, here is one such design. Now, we take a careful look how the design has been created. So there's one design created for pizza A, one for pizza B. So what is the design? That for pizza A, this is first design, this is the second design, this is the third design, and so on up to the 8th design. So the first design for pizza A has all zeros. That means all the base levels for the attributes 1 to 5. So to create the design for pizza B, that is the direct competitor, you simply fold over. That is, you change from 0 to 1. You just flip the numbers and you will get the alternate design for the competitor. So these are all zeros, these are all ones. So that means when you show the option pizza A to the consumer, you're going to show all base levels, that is gourmet pizza, thin crust, tin ingredients, price of $7, and 20 minutes delivery time. So these are all the base options. But for pizza B, you have shown the alternate options, that is traditional, thick crust, all fresh ingredients, price of $10, and delivery time of 30 minutes. So that's how you take the designs and you show them to the consumer. So here you are, for the same design, you're showing 2 alternatives and you're asking the consumer to choose one of the alternatives. Which one are you going to choose? Let's say you like this. So this choice is picked up. And bringing you back to conjoint experiments. In conjoint experiments, you would, on the contrary, show all the designs for all the products and ask them to rate which of these designs you would prefer the most for a consumer. So whether it is one or second design or third design, which was your overall preference. So instead of showing pizza A versus pizza B, you would give these 8 designs to the consumers and ask them to rank the designs. So that's how, these conjoint tasks differ from discrete choice experiment tasks. Now, how do you analyze the data that is collected from the discrete choice experimental model? So I just want to remind you the additional, instead of rankings and preferences, you get the choice of the consumers, whether they chose pizza A or pizza B for a particular design. So let's see how, let's progress from conjoint analysis to discrete choice analysis to give some context and put it in perspective. So for conjoint analysis, if you remember, how do we calculate? So the consumer gives us the overall preference for an option. And what we do is once we have got their rankings or utilities rankings from the survey, we calculate the utilities of the product or items for all these attributes. So these are called as the part words, right? And we calculate these using an ordinary regression. So we have our continuous variable, which is preference, that is rankings 1, 2, 3, 4, 5 on the left-hand side, and the value of the attributes on the right-hand side, that is the dummy coding. And we run the regression to estimate the beta, right? So it is an assumption that the utility that the consumer derives from an option is a linear, increases in a linear fashion. That means as the importance of the product attributes increases for a consumer, the utility of that alternative increases for the consumer. However, in choice, it is a bit different. So when the consumer does not buy a product, so you can see that the choice is 0 and it remains at 0 irrespective of the magnitude or the type of products in that particular alternative, the type of attributes in that particular alternative. If it is not chosen, it just remains constant at 0. But if a product or alternative is chosen, then we take into account the attributes that are present in that particular product. So it is, now you can see that this pattern is not linear. It is not linear, it's rather this type of pattern, right? So the probability of choosing an item increases from 0 to 1 because your utility for the item chosen was higher. So we get a different type of curve in this case, which is not linear. So assuming that, when people make choices, it's because their utilities increase in a linear fashion would be a misrepresentation. Given the nature of this graph of the buying pattern, we need a different type of model. So how do we model the choices of the consumers? On the left-hand side is the choice column, right? Whether the consumer bought the product or did not buy the product. On the right-hand side are the product attributes. Again, they may be dummy coded. There may be marketing mix variables such as the price of the products, importance, weights. So we have to calculate, similar to conjoint, we have to calculate the part words or the importance weights for those attributes. But how do we calculate? Because our dependent variable now here is 1 or 0. It is not continuous like rankings. So for that, it is important for us to understand the concept of utility. So in choice model, we relate the attributes to the choice via utility. So what we're trying to say is that consumers will choose a product if they derive a higher utility from that product. Now, this choice is 1 or 0, but utility can be a continuous variable. That is any number between, say, 0 and 1, or even higher, or a negative number. So it can be, let's say, any number between -1 to 1, right? So this is just to illustrate the concept. In other words, it is continuous variable. So once we, to understand these choices, we have to understand the concept of utility. So we link the attributes to the choices via utility. And for that, to link the utility to the choices, we use a special class of models called as the logit models. And the ordinary regression does not work over here because the dependent variable is, it is 0 or 1 binary. It's not a continuous variable. And so that is why we have to link this binary variable to the attributes via this utility. And the utility is assumed to be latent. It is, the consumer has not indicated that in the form of a number, but we have to infer it from all the data that we have, right? So that is why it's called as the latent utility. All right, so this is a formula of a logit choice model. Now you don't have to memorize this, but it's the idea behind this model is how we relate the choice of a consumer to the latent utility. So this is latent utility. This is the choice, the probability of choosing an item I by consumer N is the exponential of the latent utility derived from that item divided by the sum of the utilities of all the other alternatives. So that is the key part. So for example, if you're choosing sparkling wine, let's say the consumer went to Coles and bought a sparkling wine. So to understand the probability of choosing that sparkling wine, we relate. So the formula says that the probability of choosing a sparkling wine is the latent utility derived from that wine divided by the sum of utilities of all the wine options available to the consumer. In simplest words, it means that the consumer chose sparkling wine because they derived the highest latent utility, unobserved utility from that bottle of sparkling wine compared to all the other options present in the store. So this is how we are creating a link between latent utility and the choice. So that is the whole idea here. Now, if you want to go a step further and make it even more, design the experiments in a more richer way to elicit more data, so you can make them slightly more complicated. So for example, in the previous examples, we looked at pizza A and pizza B, and the consumer was asked the option that which pizza would you choose? But now in the more complicated versions, which are called as the best worst choice experiments, you can ask them which is your best choice and which is the worst choice, instead of asking them, will you buy it or not buy it, right? So that is called as the best worst experiments. So you will be able to get the best choice, you are able to get the worst choice, you are able to do analysis on an individual basis and probably draw out more information as well. Okay. So here is an example of best worst design. So again, this is the choice of wine and all different attributes for all the options have been given. And the question is asked that you have seen all the wine descriptions. Please select the wine you prefer the most. And the next question would be, please select the wine that you prefer the least. So that will give you the best preferred option and the least preferred option. So that's how these experiments are designed. So in this particular lecture, we have seen that how you can, engage in the new product design process by designing the, by trying to elicit information from the consumers, much more richer information than what conjoint can give you, by designing these so-called discrete choice experiments or best worst choice experiments, because you can create more sophisticated, more complicated designs with more options and several attributes, which is a limitation of the conjoint design. So for those of you who are interested in learning more about this, here are some, names of the books given over here, and also articles that you can read. So researcher McFadden actually worked, he got a Nobel Prize for his work on choice models. And at UTS itself, there's tremendous amount of research done using choice models. So that is about this lecture. Now we are going to talk about the conjoint simulator. All right, so now let's discuss the conjoint simulator. So the conjoint simulator, here is the file in which we will discuss one example of the data that comes in through the survey conjoint survey and how you are going to analyze that data. So imagine that if you have to do the same exercise for your project data, how you're going to work through it. So I'm going to run you through the steps. So here is an example of a conjoint design that was given to an individual consumer, and the consumer was asked to rank the different options. So there are three designs given to the consumer, A, B, and C. So these are the, so one attribute is design with three levels, that is three types of designs, A, B, and C. The second attribute is brand, so there are three brands. And the third attribute is price. So again, there are three levels in here. And fourth attribute is approved, which has two levels, yes or no. And the fifth attribute is guarantee, which is again, yes or no, that is two levels. So these are 18 designs that were given to the consumer, and the consumer has provided their rankings. For example, for this design, the rank is 13, and the most preferred is design number 18, that is design C with brand 3 and price of 1.19, approved yes, and guarantee yes. So what, as part of our analysis, the very first part of our analysis, you have to convert, you have to dummy code the variables. So for example, here, this is, so the rule of thumb, you have to remember this, the rule of thumb. If there are three dummies, you include only two dummies in the analysis. So if there are three dummies for three levels of an attribute, then you include only two dummies in the analysis for that attribute. So remember this rule of thumb. Now, let's take an example and see how this rule of thumb applies. So the first attribute is design. It has three levels, A, B, and C. We have to code them in the form of dummies, that is 1 and 0. So our rule of thumb says that because there are three levels, that means we have to code three dummies, but we take really only two of them in our analysis. So when we are converting these, this design to dummy variables, for design, we can only code these two options, A and B. It is up to you which two you want to take. You can code B and C or A and C, totally up to you. So here, for design A, wherever you come across design A, it has been coded as 1. And for example, let's take this particular case. The very first row is design A, so it has been coded as 1. And for this case, the dummy for design B takes a value of 0. So the first three cases you see, they are design A. So the design A has been coded as 1. In the next three cases, it is design B. So the dummy for A takes a value of 0, but the dummy for B takes a value of 1. Now let's see, in the very first design, the brand is 1. So the dummy variable for brand 1 takes a value of 1, and the dummy variable for brand 2 takes a value of 2. Now again, remember, there were three levels to this attribute, that is 1, 2, and 3 brand, but we have included only 2 in our analysis, and so on. So you will do the same exercise. Approved has only 2 levels, yes or no. So that means you only need to create one dummy variable for approved. So here, approved is has a label of no. So you put a value of 0. For the second design, for the third design, approved has a value of 1. So we is yes, label of yes. So we put a value of 1 over here. So essentially, dummy coding means you are converting the labels to numbers so that you can use the data in regression analysis. Similarly, for guarantee, let's take a look at the second design. It is a yes. So the dummy for guarantee will take a value of 1. And then you have the ranks. So the highest rank given by the consumer is 1 because that is the most preferred option. And the last one is 18. So what we are going to do for the purpose of regression analysis, we are going to reverse code it in the sense that this ranking 1, which represents the best option for the consumer, we are going to convert it to the highest number. Now, how do we do that? So let's take the example. Let's start from here to make it easier for you. So we know that there are 18 designs, okay? So we add, when we are converting the rank in the reverse order to the reverse order, where, so here the smaller number represents the highest choice, but now in the new ranking system that we are designing for the reverse order, 1 will represent the lowest choice and the higher number will represent the higher choice. So to convert that, we take the total number of designs, which are 18. So 18 plus 1 minus this rank that the consumer has assigned. So that converts to 6. And so you do the same exercise for all of these, and you will notice that now 1 has been converted to 18. That means the 1 was the best choice for the consumer. Now for regression analysis, we have converted that to a higher number 18, which represents the highest utility for this particular consumer. That is the highest preference for this consumer. It is easier to work in the descending order in regression because you are able to interpret the coefficients much more easily. And that's the reason why we are converting the ranks rank order. Okay, so these are the numbers. So this is the conversion that you now see over here, right? So when we do the regression, we are going to take all these dummy variables as the independent variables, and this will be our dependent variable in the analysis, all right? Okay, now let's go further ahead. So after you have done, so this is, remember, the data for one consumer, and we are going to do the regression analysis on this data, and the output is given over here in this particular sheet. So the one point to remember is that if you have 20 consumers, then you're going to run the regression 20 times using the data of each consumer, right? So for one consumer, you run the regression. If you have 30 consumers in your data set, then you are going to run the regression 30 times. When you run the regression, you're going to get the output. Now, in the output, you will see the values for the coefficients. Now, we all know that the coefficients represent the part words, right? Or the sub-utilities for those individual attributes, levels of those attributes. So this is the intercept, which represents the baseline preference of the consumer. If all of these attributes were not taken into account, they were set to 0. Now here is the preference or the part worth for design A, design B, brand 1, brand 2. So this consumer, if we want to understand, has a lower utility compared for design A as compared to design C. So how do you interpret the dummies is also very important. So remember that we included 2 dummies, A and B, in our analysis. But there is also a third dummy, C, which we did not include, and that is assumed to be the base comparison category. So if we see a number negative 4.5, the way to interpret this is that the overall, the utility, consumer derives a lower utility from design A as compared to design C. The consumer derives, this individual derives a higher utility from design B as compared to design C. And so when you write these utilities, what is the utility of design C? Here it is. We assign all the dummies that have been excluded a utility of 0. So A minus 4.5, B is 3.5, and dummy C that was excluded has a utility of 0. Similarly, brand 3 was excluded, it has a utility of 0. So these are the part words, and they represent the utilities for those particular levels of the attribute. And similarly, this is the price. So 1.19, 1.39 were included in the analysis. This was the base dummy that was excluded. So it has a base level utility of 0. So I hope this concept is clear. And you can plot these part words. So the way to convert these part words to utility is a very simple formula. So you take the part word and you subtract it from the minimum of these. So that means 3.5 minus the minimum, the smallest number here is negative 4.5. So 3.5 minus negative 4.5 is actually, it comes to 8, divided by the total number of coefficients you have estimated, excluding the intercept, right? So 1, 2, 3, 4, 5, 6, 7, 8. So you have estimated a total of 8 coefficients. So if you look at this formula, it is the part word for B minus the minimum of all these 3 part words divided by the total number of coefficients estimated. That will give you the utility for this particular level. This is a utility 0.56 for level C and 0 utility for level A. And then you can plot these utilities to see the movement and how they vary across the different levels of an attribute. So you can do the similar exercise for all of the attributes given here to understand the consumer derives a higher utility from which of the attributes. This is the example given for one consumer. Now, what do these attributes tell us? So this was, let's say this is the intercept. These are the coefficients for the individual consumer. And this was the design that was shown to the consumer. Now, let's say our brand is 1, competitor brand is 2, and the next competitor brand is 3. Same way, the price is 1, 2, and 3. For price is 1 for our brand, competitor brand 2, and level 3 selected for competitor brand 2. So what we can do is we can replace all these numbers with labels. So this number 1 for design represents design A. This is design B. This is design C. Now, if we want to calculate this particular individual derives the highest utility from which of these designs, right? Which of these combinations given over here. What you can do is you can write the part words, these part words for those options. So for example, for option A, the consumer's part word that is obtained is negative 4.5, right? For competitors design B, the consumer derives a utility of 3, the part worth is 3.5. And same way for design C, for the other competitor, it is 0. So just for each of these corresponding design, just keep replacing here in this particular table with part words. These are the values of the intercept for this individual, 4.83, 4.83, 4.83. It does not change. So now for, let's say this particular company is wanting to test their brand versus the competitor brand. Now add all of these part words that will give you the utility for our brand for these design options. That is Design A, brand 1, price of 1.19, which is not approved and there is no guarantee. So that is the utility. For competitor, the utility is much higher. It's for design B, brand 2, 1.39 price, but it is approved, although there's no guarantee. And similarly, for the third option, you will find the overall utility is 9.33. So this is how you can use the part words to understand from which of the options you are getting a higher utility, okay? For a design, for a particular brand level, for a particular price level, for a particular, um, approved or guaranteed level. So this is for the individual that we have tried to understand the different design utilities. Now, if you have, for let's say, the data on 14 consumers, and for all the 14 consumers, you did a regression 14 times, and you got their part words for all of these attributes and their levels. So those part words are listed over here. Now, what you can do is similarly, for each of those consumers, you can calculate the utility scores for your brand, for the competitor brand, for the design that was given in the previous sheet for this one, right? So the same exercise, you calculated the total score for this consumer. You have pasted it over here, and same way you calculated for all the other consumers. Once you have calculated this overall utility score, now you can predict the choice. So here the utility is highest from 12, and that is why you will notice that the choice, the best choice option this consumer is likely to choose is choice 2, that is this particular design. And so you can construct their choices like this based on the utility scores. Now, if you sum these choices, which are summed over here, you will notice that this particular consumer has an equal utility for our brand as well as the competitor brand, and therefore is indifferent to choosing between 1 and 2 and can probably choose both of them. And so the sum is 2. Now, to calculate the probability of choosing option 1, probability of choosing option 2, probability of choosing option 3, what you have to do is the probability of choosing option 1 is equal to, that is this choice divided by the sum of choices. Okay, so it is equal to 0 divided by 1, which is equal to 0. Similarly, the probability, now remember we are calculating the probability of choosing option 2 is equal to the choice made for option 2, that is divided by the sum of total choices. So that's how you you create the probability table of choosing among the 3 options, right? So let's say the current share for our brand is 30%, for competitors is 50%, and for the next competitor it is 20%. So these probabilities are, in other words, choices. So you can now also calculate, taking the count. So for example, how many people chose option 1? So you can calculate that over here by summing up these numbers. So if you just sum these numbers and place them here, that is 3.5. So in other words, out of a total of 14 consumers, how many went for choice option 1, that is 3.5. So once you take how to convert that to share, take that count and divide it by the total number of consumers. So that is 25%. So your current share is 30% and your expected share of the market is 25%. So this is just a hypothetical example, and the error in prediction is about 5%. Okay. So now we have looked at how we can work with the individuals' part words to create their utility scores for each of the choice options in our design and calculate the choice from that choice, we can construct the probability of choosing an option and then take the count across the number of consumers who choose a particular option and then convert that into market share. So this is the advantage of doing conjoint analysis, and this is how it helps you to understand market shares, right? So now over here in this particular sheet, it is something similar that has been done for, instead of consumers think that there are 14 segments in the market. Okay, and for all those 14 segments, the shares have been calculated over here, and the same thing goes that, so for example, over here, you have these three brand scores. So the probability of choosing this particular option is the highest. So how do you convert that into the share? So the probability of choosing this particular option, I'll just highlight it for you, is equal to this 12.66 divided by all of the three combined, 6.5 plus 12.66 plus 2.33. So you are simply converting for each of the market segments into shares, and then you add those total shares, so actual share, and then you add the total shares for our brand. So that is a predicted share for our brand. This is a predicted share for brand B. That is, you add up all of these shares across all of the segments. So if you have different segments, you can do an analysis for different segments. If you have different individuals, you can do a similar analysis for different individuals. So now let me, this was the conjoint to show you how calculations are done, and these are the steps that you will be required to conduct once you obtain your data, depending on what problem you are analyzing. Are you doing segmentation analysis, or are you studying individual choices, etc.? So now I'm going to stop sharing this file and share another different file with you. And that file is actually, this is the predictor model. So whatever steps that you saw in the previous Excel file, those are sort of coded in the background, and all you have to do is you can recover the market shares by simply entering the information of your design and the part words. So for example, in this first sheet, you can enter your design. So there were 3 designs, there were 3 brands, 3 levels of price, etc. So this is what the information that you have entered. Click on Save Specification, then click on Part Words for all the 14 consumers. So once you do that, in the third sheet, it will automatically calculate the market prediction for you. So there are 3 options. It has calculated the market share of 25%, 61%, and 14%, right? And the unit sales, all these numbers have been fed over here individually. Based on this, you can see a market shares histogram. If I reduce the market share, let's say to 2, then this will update, the market share histogram will update by itself. So the brand 1 is now 25% market share, and the second brand is 75% market share. So let me increase it back to 3. Okay. And similarly, the other thing I want to show you is that for this particular, if you want to, draw a scatter plot, if you want to plot these part words, these individual part words, then what you can do is it gives you, this particular design gives you the flexibility. For example, you want to choose between design A and design B. So it'll plot the part words for all 14 consumers for design A versus design B. You can choose for, let's say, price 1.19 and price 1.59 and click on update the plot. Then it'll show you how they are plotting together. Okay. So you can see these kind of patterns in the data. say, let's say brand 1 and brand 2. So this is kind of pre-programmed in Excel to help you understand how um, to get this information. So it's like a little dashboard, a neat dashboard that has been created. And accordingly, for each of the consumers, because you entered the part codes, the utilities will be calculated automatically, and it'll give you the choices as well. So this is the market. This is how you create dashboards, but the underlying work was taught is what you have to do in the other Excel file, the conjoint simulator that I had demonstrated to you earlier. All right, so with that, we will stop here.